Everyone, in this video I'm going to show you some examples on signals operation as well as plotting and deriving basic functions. We look at example 1. You are given with this function, okay, and you have to sketch this signal. This is a periodic signal with period t0 and frequency omega naught. So for t between 0 and t0, the signal is defined as Vt equivalent to Vm sine omega naught t multiplied by ut minus t0 over 2. So if we see here, there are two signals. The first signal is x1t, and the second signal we put it as x2t. Okay, and suppose here Vt is equivalent to x1t multiplied by x2t. We sketch x1t and x2t separately first. Okay, so first let us sketch x1t completely. Here x1t is equivalent to Vm omega naught t. So this is basically a sine function with Vm as its amplitude. Okay, so we know that sine function form is like this. Okay, and it goes on until infinity, and the peak amplitude here is Vm. So this is x1t. Since the signal is given with period t0, okay, so one whole cycle take t0, okay, and half cycle of sine function here take t0 over 2. Okay, so basically this signal is also has negative part with the bottom peak here is negative Vm. Okay, so it is going on forever because this is a harmonic signal. And then we sketch x2t completely. For x2t, it is basically a unit step function minus another unit step function. So every time you see this, okay, bear in mind this is actually a rectangular signal. Okay, so how? Let us plot this x2t signal part, which is ut and minus ut minus t0 over 2. Okay, so remember the steps to plot the unit step function, the addition of the unit step function. First, t is equal to 1 when t bigger than 0. This is for ut here. It's equal to 0 when t less than 0. And then another one is negative, oops, sorry. Okay, and another one is ut minus t0 over 2, which is equivalent to F1 because of this negative part here, when t bigger than t0 over 2. Then it is also equivalent to 0 when t less than t0 over 2. So from here, we can conclude that when t less than 0, x2t is equal to 0. Okay, because there is no signal at all. When t in between 0 and t0 over 2, x2 should be only this part, okay, so it should be 1, because for this one, okay, for the second part here of the unit step function, it only has value negative 1 after t0 over 2. Okay, and the next time range is t bigger than t0 over 2. So x2t here will become 1 minus 1, which is 0. Okay, so we have 0 when t less than 0, 1 when t between 0 and t0 over 2, and 0 when t bigger than t0 over 2. So when you want to plot this is actually a rectangular signal. Okay, so you have time between 0, okay, and then you have, if you look at the time involved is t over 2 here, okay, this is at, okay, and the amplitude involved here, okay, let's see here, let's see here, before 0 there is no signals, after 0 the signal goes to 1, and after t0 over 2 it goes back to 0. So we have a rectangular signal. x1t and we have x2t, we just have to multiply this together. Okay, so let us draw in another page here. Okay, so remember from previous page we have sine signal x1t, okay, and the period is t0, and the half period here is t0 over 2, multiply with a rectangular signal with amplitude equal to 1 and have signal only from 0 until t0 over 2. This is x2t. So basically this is very easy because any signal, okay, with the same period of time multiply by 1, okay, so this signal will only have values in between this rectangular. Okay, so you imagine that you put this signal behind this x2t. This is x2t. Okay, so if you look at the negative part here, okay, if you look at the negative part here, any signal here, if you multiply by 0, it will become 0, right? And any signal here, okay, if you multiply by 1, it will become Vm. Okay, and it will retain the shape of this signal, okay, the sine signal. Okay, so we look at part by part. Okay, before 0, there is no signal, okay, a signal amplitude, or the amplitude is 0 at x2t. So if this Vm signal, if this x1 signal multiplied by 0 is still 0. And from 0 to t0 over 2, okay, x2t has value which is 1, and x1t has value which the amplitude or the peak here is Vm. Okay, so basically the answer here is this signal, the Vt here, okay, which is the signal that you have to plot, okay, from the multiplication of x1 and x2t, only has signal, okay, from 0 here to t0 over 2, which follows this sine wave, okay, and have the amplitude Vm. Okay, so notice that after t0 over 2, there is no signal. Why? Because any signal here, when you multiply by 0 at x2t, it will become 0. So there is no signal. Okay, so basically that is the answer for Vt. Well, on the next page, now you have to sketch the signal, which is a combination of ramp signal as well as unit step function. Okay, so if you look at this signal, we know that it has a combination or superposition of 1, 2, 3, 4. Okay, this is a combination of 4 signals. So you follow step by step that I have shown you before. So first part you have 3 ut. So this 3 ut is equal to 3 when t bigger than 0, 0 when t less than 0. And then you have t ut, so it should be equal to t when t bigger than 0, 0 when t less than 0. So this is a ramp function. And then you have negative t minus 1, okay, u t minus 1. So this one is a bit tricky. Okay, basically it has to be equal to this whatever you multiply with the unit step function. Okay, because ramp function is actually a time function multiplied by unit step function. So basically you put back whatever it is before this u. Okay, so this is negative t minus 1 when t bigger than 1, because it has a time shift by 1, and then 0 when t less than 1, and we have another function here, negative 5. T minus 2 is equal to negative 5 when t bigger than 2, and 0 when t less than 2. And then combining all the signals by range, okay, first, when t less than 0, we have ft, okay, ft is the signal that we need to sketch, equal to 0, okay. And then the next time range is t less than 1, okay, because we have 1 here, okay, because we have 1 here. So when t less than 1, however, bigger than 0, ft is equal to, so you take whatever function which is bigger than 0 but less than 1, so 3 here plus t, okay, so 3 plus t, so you leave like that, you just leave it like that. Okay, after that we will solve the whole equation, and the next time range is 2. So this one, t will be bigger than 1, less than 2. So ft is equal to 3 plus t minus t minus 1, okay, which we take from function here. Okay, so don't leave it like that. You can solve this. Okay, 3 minus, basically you can cancel it away, and 3 plus 1, 3 minus minus 1 is equal to 4. And then the next time range is when t bigger than 2. Okay, so ft will become 3 plus t minus 1. Okay, and then here you have 5. And then you minus, basically it's actually 4 minus 5 if 1. So from here, you can plot the graph based on the values at each time range. 0, 1, and 2. Draw the signal which is a combination of all these time step and also ramp function. And from 0, when the signal is less than 0, we don't have any, the signal doesn't have any value, so it is 0. Okay, from 0 to 1, it has value 3 plus t. So this is when this is the time where you need to apply back your knowledge on plotting the basic graph. Okay, I believe that you have learned it before. So 3 plus t should basically is the same as t plus 3. Okay, it means that the signal, okay, the graph here intersect at 3, and it has the gradient t. Okay, so it should go like that to 4, and this one should be 1. Okay, means that in between 0 and 1, it goes up from 3, level 3, amplitude 3 to 4. Okay, and then from 1 to 2, the signal here maintain at 4, right? And then after 2, it goes to negative 1. Okay, the signal will goes to negative 1. This is negative 1. Okay, so it means that it will goes to negative 1 forever. So I put like this. Okay, it doesn't stop. Alright, so basically this is the signal ft that you have plotted based on the superposition of several signals here. We will have a look at another example 3 here. Okay, so for example 3 here, you have to derive the equation from this graph. Okay, let me draw it here. This is the graph. Starts from negative 2 here, negative 1 here, and from here it has value 1, and then 1, it's 1, this is 2. So it is a combination of ramp function and also unit step function. Okay, so you have to derive or obtain the mathematical equation of the signal. Okay, so the question can be like obtain the mathematical equation, or obtain the mathematical function, or derive the mathematical equation to model the signal. So the first step that you have to do is, remember what I said before, you have to draw a table. Okay, so the time involved here is -2, 1, 0, 1, and also 2. Okay, now how many functions will be involved depends on this time. Okay, so the time that I put here is the time when there is a changes at the signal. Okay, so there are 1, 2, 3, 4, 5 time steps required. Okay, so you will need to have 5 rows. Okay, 2, 3, 4, and 5, and finally the final row, which is the overall signal. Okay, and then you draw a line like this in between the time involved. Okay, okay, so we have first we have first u t plus 2. Why plus 2? Because the time involved here is negative. Okay, so by this time you should already well aware why we have these figures or why we have these numbers. Okay, and then u t, because this is plus, this should be negative one. Okay, it should be negative. So ut plus this should be 1 here. Okay, and then we have ut, and then ut minus 1, and then ut minus 2, and finally the whole signal, which is st. Okay, is you put the values of st at this time step. Okay, first before -2, st is 0, so it is 0. And then in between -2 and -1, you have to find out the equation here. Okay, so the equation here should be t plus. Okay, I'm not going to show you how to get this equation. By now you already should know how to get this equation. Okay, remember that I've taught in class, it's based on the graph y equal to mx or mt plus c. So you should find the gradient, find the intersection of this line at x equal to 0 at this y. Okay, and then between -1 to 0, the amplitude here is 1. Between 0 to 1, this one is 2, and between 1 to 2, okay, which is this line, okay, this one is -t plus 2. Okay, and then there should be another one line here, like a column here, which is after 2. Okay, after 2 it is 0. Okay, so how to get this -t plus 2? This is based on the gradient, which is -t. Okay, the gradient is -t, and then it intersects at 2. Okay, so -t plus 2. So from here, okay, we solve one by one. Okay, so before -2, okay, all the signals should be 0. Okay, so it should be 0. So we just put here 0. Okay, and then we solve the first row first. In between -2 to -1, okay, we just follow this t plus. We put t plus 1 in all columns here. T, okay, and then between -2 here, and then between -1 to 0, okay, for the second row here. Okay, this should be 0. Why? Because before -1, okay, there is no way that before -1 there is no way that this function is working. Okay, because before -1 only one function ut plus 2, right? Because it also related with the time here. Okay, so after -1, okay, we have to find this number here, so that when you add this column and this column here, you will get 1. Okay, so the value here is -t. So you just put -t, okay, for all the columns in the same row. And then after that is between 0 to 1. Okay, 0 to 1. So you put 0 here, okay, and then this one, this column, add this column, and add this column. Okay, the summation of all these 3 rows in the same column here must be 2. Okay, so to find out this value, I said before, you put something like t plus 1 minus t plus, let's say you put it a equal to 2. Okay, let's say this is a. Okay, so you rearrange back, you will get a equal to 1. Okay, so basically this is 1, 1, 1. Right, so solving for another row here, 0, 0, 0, and this one should be -t. Okay, and then 0, 0, 0, 0 here, this one should be t minus 2. Okay, so when you have obtained, or when you already fill this table, then finally you can write the whole equation based on the values in this table. So now xt is equivalent to t plus 1 ut minus t u plus 1. Okay, you take the value from here, and then plus ut, okay, because 1 multiplied by ut still ut, and then minus t u t minus 1, and then finally, so this is plus t minus 2 ut minus 2. Okay, so that is your answer. You have 1, 2, 3, 4, 5 different functions. You add this together, right? So for this answer, you cannot you can just leave it like this. Okay, you cannot put like ram ut plus 2, because in order for you to put this ram ut plus 2, outside the bracket of u here must be the same as this. Okay, whatever inside this. For example, here you can put here ram t minus 2. This one is correct if you put ram t minus 2. Okay, but not for this, not for this, and not for this, because whatever inside the bracket is not the same as whatever multiplying this unit step function. Okay, so I think that's all for examples in this video. Sorry for the messy writing here, and I will show you some more examples in the next video. Thank you very much.